Thanks for stopping by to check out yet another episode of Vintage Audio Review. In this episode, I'm going to talk about the Marantz Model 2330 AM/FM stereo receiver. It's not right in front of me, so you're going to see an inset of it because I had to give the original back, and the original video clip that I shot was destroyed accidentally. So be that as it may, in 1976, Marantz sold the 2330 for about $790, which would be about $3,600 today. It was very pricey back then. It's a fairly heavy receiver. It weighs 50 pounds, and it was rated at 130 watts into 8 ohms at less than 0.07% THD. So as usual, I will show you a tour of the front and the back of the 2330, as well as I'll remove the cover and you can see the inside of it, and then I'll show the measurements I made on it and then talk a little bit about how it sounds. I should point out that my buddy Richard had brought me the 2330 to check out for him, and when I hooked it up I noticed the sound was bad. In particular, one channel was not giving much output. I kind of put it away for a while, and eventually when I got back into it I decided to see if it had pre-out main-in jacks so that I could determine whether it was the preamp section that was bad or the power amp section that was bad. And it does have pre-out main-in jacks. However, there was no jumpers in there, so it was not connecting the preamp to the power amp. I got some jumpers from our good buddy Ian, and then everything worked fine once the pre-in main-out jacks were connected together. I didn't have to do anything to the 2330 other than test it, and I just thought it would be important to bring that up. Here is a closer view of the Marantz Model 2330 powered on, so you could see how nice the display looks with all the lighting. Probably the most iconic thing about this receiver, or Marantz vintage receiver, is the gyro tuning knob there. It has a great feel to it. It's big, and Marantz receivers that have that knob are highly sought after, it appears. Over here is our power button. We have a headphone jack button here. These two guys right here, those are our speaker on-off switches for 2 sets of speakers. You have a loudness button here. We have a 9 kilohertz filter here and a 15 hertz filter there. Our volume control is that guy right here, and here is our treble control, mid-range control, and bass control. The bass, mid-range, and treble controls do have 2 parts to them, so you can adjust either the left or right balance as you see fit. There is also a main left and right balance right there. We have what is called our tone mode switch, which is this guy right here. It has an off position which bypasses the 3 tone controls. I guess that would be like a CD direct mode today. When you have it in the on position, you can use the 3 tone controls. It has a 100 hertz position right here, and if you have it there, the turnover frequency of the bass tone control is shifted from 500 hertz to 100 hertz, while the mid and treble controls operate normally. There is also a 10 kilohertz position of that switch over here, and when it's in that position, the turnover frequency of the treble tone control is shifted from 2 kilohertz to 10 kilohertz, while the bass and mid operate normally. And if you put it to this final one right there, that is the 10 hertz, 10 kilohertz, and in that position both bass and treble are affected above while mid operates normally. So it does have a lot of options with your tone control settings there, and there will be a plot showing kind of the effects of some of the settings. This guy right here is just called a mode switch, and you can select either left or right. When it's on left, the left channel signal is routed to both right and left audio channels. If it's on right, the right channel signal is routed to drive both left and right audio signals. Stereo, the normal position, and reverse, it would reverse the left and right channel signals to the opposite channel. And it also has a mono left plus right, and in that case the left and right channel signals are mixed and routed to drive both right and left audio channel speakers. That has a note when playing a single channel source such as TV or AM radio, set the switch to either left or right position or to mono left plus right so that the single channel source can be heard through both speakers. So it does have also some tuning meters. The tuning meters, it has a signal strength for either AM or FM. It also functions as a multipath meter when the multipath button is depressed, which is that guy right there. And the FM tuning meter, this is the signal strength multipath meter right here, and here is our FM tuning meter. When you have tuned in your FM station appropriately, the needle would point to the center when you have your station tuned in. The multipath button, it says, is used when you have a rotatable FM antenna, and you can further optimize FM reception by pointing the antenna in the proper direction for minimum multipath. So that's kind of a very nice feature. So that's kind of it in a nutshell. It also has an MPX noise filter switch, which is this guy right here. And it is useful for reducing noise on weak stereo FM signals with excessive noise and/or interference. When activated, the MPX noise filter slightly reduces separation at high audio frequencies. This offers moderate separation along with considerable suppression of out-of-band phase noise and distortion components. Unlike most noise filters, the MPX noise filter does not sacrifice full frequency response. That is kind of a tour of the front controls of the 2330. Now we will look at the rear panel of the 2330. One very important thing I forgot to mention is the selector control, this guy right here, and it gives you a choice of AM, FM, Dolby FM, Phono 1 or Phono 2, and auxiliary. Now both of the phono inputs are for moving magnet cartridges. I forgot to mention these two guys here, which both relate to your tape monitor circuit. This guy right here is your tape monitor switch, and it has three positions. You have position 1 or tape deck 1, your source or tape deck 2, and these two dubbings, there's an in and out dubbing, and those would replace your tape monitor 2 input and output jacks in the rear. So it's mainly designed, I think, for use in tape decks where they use 1/4 inch jacks to connect to the particular tape deck. This obviously is the rear of the 2330 receiver. Starting off over on the left, we have our connectors for both sets of speakers. They're the kind you push in and then insert your speaker wire. We have an unswitched AC outlet and a switched AC outlet. We have a user replaceable fuse. We have our AM antenna rod there. We also have an output that could be used for a FM quad adapter during that time period. They thought they may have some stations that would be transmitting in quad, and this would allow you to put a signal into an optional adapter so you could get quad FM. Here are the pre-out main-in jacks. Going on, we have our tape monitor input and outputs. This is monitor 1, monitor number 2. If you use the dubbing jacks in the front, they take the place of those connections. We also have two phono inputs. We have phono 1 and 2. We have our 75 ohm FM antenna connection. We also have a 300 ohm or 75 ohm antenna connection, and we have our AM antenna connection there. So this guy right here is a muting level adjustment, which is a little bit unusual. And it says, in the absence of an FM carrier, all FM receivers produce noise. This noise is apparent while tuning between stations. The FM muting push button on the front activates circuitry features in the model 2330, which mutes the audio outputs when tuned off station. The muting level control on the rear panel determines the threshold level for the muting circuitry. Maximum muting is achieved by setting the muting level to max. To prevent muting very weak stations along with the noise, the muting function may be turned off by releasing the FM muting push button. So that is kind of what is going on there. So that is a tour of the rear of the 2330. So here we have the Marantz 2330 with its cover removed. The first thing that jumps out is this big power supply transformer with the Marantz logo on it. We have our two big filter caps right there. They are 15,000 microfarads at 95 volts each. So these guys right here are the pair of rectifier diodes. There's two diodes inside each case. I had not seen any rectifiers like that before. We have everything for the tuner, the AM tuner labeled, and as well as for the FM and AM tuner over here labeled, and more tuner stuff down there. The power amp section are right here and right here. I'll do a side view on one of them so you could see the transistors that they've got going on there. As far as I can tell, we have all original capacitors. It looks like this probably is a speaker protect board maybe, and although the capacitors have the plastic around them kind of not fully at the top, it doesn't necessarily mean that they're bad. Anyway, we'll see what the measurements tell us on those guys. We do have our speaker protect relay here, and that's kind of just the technology that was going on back in 1976, or I guess if we move this right here, we have a part of the label that says 1977, a manufacturing date right there. I thought these were only made in 76, but maybe they were made in 77 as well. And so that's kind of a tour. We'll go look at the side of the unit in just a moment. Here is a close-up view of one of the amplifier boards. You can see there's some pretty good heat sinks. We also have adjustments for idle current and DC offset. And then we have 4 output transistors. There are 2 PNP and 2 NPNs. This is a class AB amplifier. So that kind of rounds out the tour of the inside. I guess I could swing over here. So that is the other power amplifier board, and you can kind of just see a little bit different view of it. Here we have the THD SNR plot at 1 kilohertz with the 2330 putting out approximately 5 watts into 8 ohms. The volume control is set that we've got about 20, I'll call it 29 dB of gain, and you can see that the THDs are rather low, 0.003% and 0.04%. The left channel is a bit worse than the right channel, and if I get rid of the right channel, you can see this third harmonic right here is the reason why, and if I put on just the right channel, you can see that it's much lower. So as far as I know, this is the way that it came from the factory in 1976 or 1977. Also, our SNRs are about 82 dB, which is pretty decent, and the THD plus noise varies depending on the channel. 68 dB for the left channel and 81 for the right channel. Here we have the frequency response of the Marantz 2330, and this is with the input going into the auxiliary input, and we are driving a 8 ohm load with 5 watts, and this shows a flatness of, at worst case, about a half a dB for the right channel and maybe 0.3 of a dB for the left channel. The channel balance is maybe 0.2 of a dB, so overall this looks really good. Here we have our standard THD SNR plot at 1 kilohertz with a 6 dBV or 2 volt RMS signal going to the auxiliary input of the 2330, and the volume control is adjusted such that at the preamp output we have 2 volts going out, so we've got 0 dB of gain. Now I will point out that I did have to adjust the balance control slider such that the left channel was favored a bit more than the right channel in order to get these gains to be the same. And we do have a pretty good SNR. It's at least 81 dB. The THD is really low at, we'll just call it 0.002%. And we have at least 81 dB of THD plus noise, worst case. So overall, it's looking pretty good. I also want to point out this guy right here. This is the 60 hertz hum, and it is 83 dB down from the 1 kilohertz reference signal over here. I would say that's pretty darn good considering this unit is about 46 years old and has the original capacitors. If I do click on the A weighting, that the hum will drop down, the 60 hertz hum will drop down to 107 dB just for grins. But the A weighting kind of adds some bandpass filtering around the 1 kilohertz, and it attenuates stuff outside of it. So anyway, that's kind of what happens when you put on the A weighting. And the SNR also improves when you do that because this hum level is dropped down. Here we have the frequency response of the Marantz 2330, and this is with a signal applied to the auxiliary input and the gain adjusted such that we're getting 2 volts out, which is the 6 dB signal level you see right here. The channels are extremely well balanced. I mean, we're talking 0.2 dB from here to here. That's very small. So our frequency response is pretty darn flat, maybe not even 0.3 dB flatness across the band. Both channels are extremely well balanced. Now, I should point out that I did have to move the balance control more towards the left side of the balance control slider, as if it were dead in the center, there was a bit of an offset. So I did adjust it so that the gain between the left and right channels was pretty darn near identical. Here we are looking at the THD SNR plot at 1 kilohertz with a 7.75 millivolt signal being applied to the Phono 1 input and being measured at the tape monitor 1 output. We can see that there is about a 40 dB gain through the phono stage. Our THD is very low, 0.002% we'll call it. The SNR is not overly great. It's between, we'll say, 45 and 48 dB. Now, that is mainly due to this guy right here. This is our 60 hertz hum, and it is about 48 dB down from the 1 kilohertz. We're also seeing a fairly nice peak over here from the power supply at 180 hertz as well. If you are wanting to use your phonograph with this particular Marantz receiver, you would most likely want to have it recapped, or at least start with replacing the caps related to the phono stage. Here we have the frequency response of the Phono 1 input to the tape monitor 1 output with a 7.75 millivolt signal applied. The frequency range is 20 hertz to 20 kilohertz as always, and we have a flatness of maybe half a dB on the low end of the band to maybe plus 0.7 dB on the high end of the band, and the channels are matched to within maybe 0.3 of a dB at worst case. So for something that is this old, it doesn't look overly bad as far as its frequency response is concerned. Here we have the THD SNR plot at 1 kilohertz for the Marantz 2330. I have a signal right now, it's minus 2.5 dBV going into the auxiliary input, and what I'm going to do is start to increase the amplitude of the signal going in by half a dB, and we can watch what all is happening as far as the output power and the THD and the SNRs, and see how close we can get to the specification, which is 130 watts into 8 ohms. So we'll slowly increase it. We're still doing pretty good. We're at, depending on, about 93 watts. Our SNR is still above 90. Our THD is less than, we'll just say 0.1% for both channels. 110 watts, 117. Oh, there we go. We're at 130 watts into 8 ohms. That is the specification. It says the THD should be less than 0.07%, which we are. And the SNR should be better than 90 dB, and we're going up and down with that, so we're close to 90 dB. And you can see that our 120 hertz, let me turn the right channel off and put a marker over here. So this point right here is 120 hertz, which would be from the power supply, and we're at 95 dB. We're 95 dB down, which is pretty good with the amplifier running at full power. It seems to be pretty stable for the most part. Let me get the right channel back on. Hopefully that shows up. And this shows you the level of the harmonics. Here's our fundamental. Here's our second harmonic, and this is our third, fourth, fifth. So it does look like the odd harmonics are indeed higher in level than the even harmonics, which is kind of what you would expect with a solid state amp. Now, if I go ahead and increase the signal level a little bit more, this thing can put out 145 watts at just 1 kilohertz, and that's where we are. So at 145 watts, we're still looking pretty good. We're meeting SNRs and the THDs. So my hat's off to Marantz. So that is very good for an amplifier that is almost 50 years old. This plot shows the crosstalk or isolation between the left and right channels. In this case, a 6 dBV signal is being applied to the left channel, and the right channel is terminated into basically a short, and I am measuring the amount of leakage of the left channel into the right channel. This is measured at the preamp output, and the volume is set such that we would have 0 dB of gain going through the system. Basically, our worst case isolation is maybe 44 dB at the high end of the band over here at 20 kilohertz, and then it improves all the way down to about 100 hertz, and then at 60 hertz we're only about 56 dB of isolation right here, and then it slowly goes up to 70 dB of isolation. There really is not a spec for the isolation or crosstalk between the left and right channels. I just kind of wanted to show how it performed that way. This is a plot of the output impedance of the Marantz 2330, and it basically shows an impedance through most of the frequency area of about 0.24 or less, depending on the channel. We'll just call it 0.24. If you want to calculate the damping factor, you would take 8 divided by 0.24, and that would give you 33.3. The specification that Marantz gave for a damping factor was 60. So we're not there on the damping factor from 1976-77. However, 33 is still pretty decent. Here are the results from the multi-tone test on the Marantz 2330 receiver, and this is with it putting out 5 watts into 8 ohms, and basically it's looking like it has about 14 bits of distortion-free range. This plot shows the THD versus frequency for several different output power levels, and the way to look at it is that the R is for right channel and left is for left channel, obviously. The 2.0 means that there was a 2.0 dBV input signal level, which translates to 147 watts at 1 kilohertz. If we go to 1 dBV, that's 117 watts at 1 kilohertz. 0 dBV is 93 watts at 1 kilohertz. Minus 1 would be 74 watts, and that's watts into 8 ohm. Minus 2 is 59 watts into 8 ohms, and minus 3 is 47 watts into 8 ohm. The really big takeaway is that the worst case distortion would be 0.02, 0.03, 0.04, less than 0.05% THD worst case distortion at 147 watts or thereabouts. So this amplifier is doing an outstanding job at its THD versus frequency level for a pretty high output power, which would be 147 watts or thereabouts. So right now we're looking at the THD SNR plot at 1 kilohertz with a 7.5 millivolt signal applied to the Phono 1 input, and we are getting about 72 watts into 8 ohms with the way that the volume control is set. We're close to a, we'll call it 69 dB SNR, and our THD is, we'll call it 0.04, 0.05%. Worst case, and the THD plus noise is between minus 62 and minus 69 dB. You can see we have a lot of gain. We're at 70 dB of gain. Also, these guys right here, these are the 60 hertz, 120 hertz, 180 hertz, or 240 hertz power supply hum points, I guess I would call them, and they are at least 90 dB down from the carrier at 1 kilohertz. So you're not going to hear these, and At this power level, you're going to be fine using this receiver's phono input from what I can tell now looking at it. I don't know that you necessarily would have to replace the capacitors in the phono stage at all, because this is pretty loud. You're not going to hear these guys. Here we have a plot of the crosstalk between the left and right channels. In this case, the signal is applied to the left channel and the right input is terminated into a short. The level of the signal is minus 12 dBV going into the left channel, and the volume control is adjusted such that we have 5 watts into 8 ohms at the output. Looking at the right channel, we can see that our isolation or crosstalk between the channels is anywhere from a maximum of maybe 48 dB over here, and we do have a little peek through over here at 58, but for the most part it's under 60 dB for probably most of the band. There is no specification on it. This is kind of just how it looked with the power amp and the preamp connected together. Here we have the THD SNR plot at 1 kilohertz, and we have a 2 volt RMS signal going into the auxiliary 1 input, and I'm measuring the preamp output. And what I wanted to do was see how much gain we could get before the preamplifier went into distorting the input. So right now we're at about 4.2, 4.3 volts, and if I go up just a little bit more, there's 4.4 volts, and we're still okay right there. If I go a little bit more, there's 4.7, 4.5 volts depending on the channel. We're still okay. I go a little bit more, and you can kind of see that the left channel in particular has degraded, particularly the THD plus noise. If I remove the left channel, you can see the right channel still looks pretty decent, but the left channel we're right around 5 volts, we'll just call it, and that probably would be about the most you would get out of this preamp if you wanted to drive a power amp without distortion getting kind of bad. This busy plot shows the effect of varying each of the tone controls a little bit, as well as the loudness switch, what happens when you press that on. Plus there is also the normal flat position where the tone controls are bypassed, as well as when the tone controls are all set flat but the tone mode is switched in. There is that response as well. The THD SNR plot at 1 kilohertz with a 7.5 millivolt or minus 42.2 dBV signal applied to the phono 1 input, and the volume control is adjusted so that we get about 130 watts into 8 ohms as an output. And the reason for that is there is a specification for the phono input stage that at rated output, the SNR should be 78 dB or better. We're not quite there, but we'll call it 70 dB, and our distortion is still looking pretty good. And overall, this is pretty darn good. Now, this would be a pretty loud level to be playing at, but you can see that the hum, the 60 hertz hum and the 120 hertz hum is down about 70 dB at least from the center frequency here at 1 kilohertz. Anyway, that's kind of just how it compares to its specification from 46 years ago. Not bad. For my listening test, I paired the 2330 with my KEF 107 loudspeakers, and it drove them just fine. I was able to go as loud as I wanted to, and there were no deficiencies in the sound as far as lack of bass, lack of treble, too much bass, too much treble. It just did a great job with the speakers. I liked listening with the loudness control on most of the time, and this one works rather nicely. It never got more than normally warm at the top after playing loud, and it just works really well. It's just a beautiful receiver. It performs well. I did connect that little IR remote control volume control that I did a review on a few videos ago, and it worked well in either the tape monitor loop or the pre-out main in jack loop, I guess you would say. it made it a lot easier to use this rather than have to get up to change the volume. That little device is a great device. But with the Marantz, it just works well. It looks great. It's got a lot of quality, and to be 46, 47 years old and meet all of its specifications for the most part is pretty impressive. I think it was off a little bit on the frequency response maybe for the phono stage, but for the most part this just did a great job. It still has plenty of power, and I can understand why people seek the vintage Marantz gear. The one complaint that I have is, well, actually I have two complaints. The first complaint is that it only has one auxiliary input. It would be nice if it had a second auxiliary input, and you could still use a tape monitor input if you wanted. So that would be the main thing. It would be nice if it had at least one more auxiliary input. My other complaint is that I don't own it. So it is somebody else's, and that's just the way life rolls. So be that as it may, it's a great receiver, and I thank him for allowing me to test it. So once again, if you like the video, hit the like button. I guess if you don't like the video, you could hit the dislike button, but let's not do that. Also, if you have not subscribed to the channel, it would be great if you did subscribe, and I am always anxious to hear comments that people make in the description below. And until next time, I hope you have a great day or night.